Hello, so in this presentation, I want to share how I've done my sidewalk segmentation. So this is my code. On this notebook, this is where I mainly do most of my training on. So firstly, you'll load the Hugging Face dataset, both train and val. And then because it's in byte string, so you need to convert each row into a string numpy string. This function allows me to return an image object that can be opened by pillow and a binary image array. So I've done that for both the TIFF column and the label TIFF column. And then before appending those into the list I've created, I need to filter out the ones that has no sidewalks on it. So this is indicated by a complete array of 0, an array full of 0. So after that, you can access each row value and see what it looks like inside. So the values here is the first one over here is for the mask. It's one of the masks, and they're all in 0 and 1. So 1 indicates where there is sidewalk, and 0 is where there's no sidewalk. That will be used for the prompt later on. And this is the image pixel array. And then you need to create that into a data frame. So out of the 10,000 images I have iterated through, there is only 2,820 of them are that showed with sidewalk mask on it. So in order to avoid having to rerun the above steps every time I want the data set, I will store this into a pickle format file and then use that to convert the numpy array to pillow images and store them in a dataset dictionary. So my dataset has 2,820 rows. And yeah, again, just to check, if you get one row from this dataset and plot them, it will show the training set, and this is the image and the mask. After that, this section is just to check whether the get bounding box function in the tutorial works. So as you can see here, the original image is like this, but with the bounding box, it will crop, so both sides is removed to where there is the sidewalk, which is this white line over here. Then onto the training loop. First, I'll need to initialize the SAM processor, and here I actually modified the configuration of it. So you can see that if you go to the SAM actual Hugging Face repo, there will be a JSON file containing its preprocessor configuration, and I copied that and create a similar one locally, this one over here, and I changed this to false so that it won't normalize the dataset that I passed into this instance over here. So this allows me to prevent it from normalizing, because I noticed that when I normalize as usual, as the default setting of the processor, I got negative pixels, which I don't want. So after turning that off, I checked it again, and the pixel value will fall into the range from 0 to 1. There is no negative pixel anymore, and the tensor array looks like this. After that, we will also initialize the metrics and the pre-trained model. This is just similar to the tutorial. And then for the metrics, I changed the atom a bit so that it also considered the learning rate and the momentum coefficients. And then I tried multiple loss functions. So I tried dice cross entropy loss and focal loss and turning sigmoid on and off. But in the end, I noticed that focal loss did the best out of all the ones here. And then this is the main training loop, because it often crashes in the middle, or it stops and it takes a really long time. So because things like dimension issues happens all the time, so I created this CSV file where I can store all of my loss and IOU. So as the training loops runs, it will store the loss and IOUs. But since I'm only doing one epoch when I run this locally, I will only be storing the batch loss and the mean epoch loss, and same with the IOU. But because there is only one epoch, so I can only have like one mean epoch loss and epoch IOUs. So I will be using the batch losses and batch IOUs to plot my metrics. So this is only one epoch, but at each batch I'll be printing the metrics out, and then afterwards I can get the loss of iterations and also the IOUs iteration, store them into your JSON file so that I can load it again. So this is the loss over batch and this is the IOU over batch. Then after that, we can check how it's done. This is the architecture of the SAM model. Then you can check the training set, how it's done on the training set. So here can I find that they have this probability threshold where you can change it and move it up and down, increase it and decrease it, so that it shows that is the confidence level, and you can show how you can, based on the probability map here, and you change that threshold to visualize a clear prediction. This is the true mask. This is the predicted mask, predicted array that plotted into this figure, and this area over here shows that this is the noise. Yeah, probably misclassified this into the sidewalk. So I treated the val dataset from Hugging Face as my test set, and it went through the same preprocessing as above, and this is the output. So the true mass is actually a straight line, but there's still a lot of noise over here. But the confidence level is pretty high. It's around 0.9 for this one. This is deployed on Hugging Face Shiny Space. Before that, I wanted to show you the prediction, the notebook where I've done my prediction on the screenshot. So this screenshot is taken from Google Earth. It's basically the same process, but I want to print that before copying the code to Hugging Face. Then yeah, so this is the end result, and we'll go to the app where I've done my Hugging Face UI web app. So there will be a sidebar. There'll be a sidebar and a UI in the input file. Then there'll be an output plot where it's basically similar to this plot over here. So let's demonstrate that by doing shiny run on the terminal. So it will build a Docker image and allow me to run locally. This is already deployed, but just to make it faster, I will demonstrate it when running locally. So I will take a screenshot from Google Earth. So for example, I'll take a screenshot of this area over here. And then this is the online version. This is the local one I'm using to demonstrate. So I have printed the process of it in my Docker terminal. So it has received the image and it shows the dimension. Then it is predicting. After the UI received it, it will go to the server. There will be a function in the server where you block the graph and you predict and plot the graph. So it will import another Python file called run. This is where I did most of my prediction, and then it will return the probability mask, then the probability map. So here. So it says plotting, so it means it's already plotted the graph. And if you go back, yes, so this is the final output. If I increase the threshold a little, I'll be able to see the prediction clear without the noise. But yes, this is the final output of my my project. This is the end of my presentation. Thank you for your attention.